we are going to discuss about non-flow work or closed system work. For deriving the non-flow work, consider a piston and cylinder arrangement as shown in the figure. This piston and cylinder arrangement consists of a certain mass of gas which exerts a pressure P on this area A of the piston. Because of this pressure, the piston starts moving from state 1 to state 2 through a distance of x. As we all know that pressure is equals to force divided by area, we can write force is equals to pressure into area. And work done by the gas on the system must be W is equals to F into X. Here, for deriving this non-flow work, we are taking very small work or infinitesimal work. Let us consider this piston is moving through very infinitesimal distance, that is dx. Therefore, dw is equals to F into dx, where this bar dw bar indicates it is an inexact differential or a path function. Work is a path function, therefore we can write it like this. Now dw is equals to p into a into dx, but a into dx, area into distance, means infinitesimal volume, means dw is equals to p into dv. When we plot this pdv on a pv graph, it will give the work. The work under this curve will give the area under this curve will give the work. So the area of this one is dv. It's very nearly equals to a rectangle, therefore p into dv. Therefore work is equals to p into dv. Area under pv is equals to work. And one more important point to remember is work is a path function. It is not a point function. How can we prove it is a path function and not a point function? Now let us consider the following case like this. When it changing from state 1 to state 2 through undergoing two process which follows path B and a path A, but the endpoints are same. As these two states or two process follows the different paths, definitely the area is different. So the area under this curve will give the WA, or the work done by the process 1 to 2 through path A, and the area under this curve will give you WB, or work done by the process 1 to 2 through the path B is WB. As the areas are not equal, means WA is not equals to WB, even the endpoints are same, but the works here are not same. Therefore we can conclude that work is not depending on the endpoints, and it directly depends on the path followed by the system. Therefore we can say work is a path function and it is not a point function, and it is also an inexact differential. Work is not a property because it is independent of the end states. Now where can we apply this PDV work? This PDV work or non-flow work for a closed system, it must satisfy three conditions. If the system is a closed system, yes, we can apply this PDV work. Our work should cross the boundary. If it doesn't cross the boundary, then we cannot apply this PDV work here, and the process must be a reversible process. If the thermodynamic system satisfies the three statements, then we can apply this PDV work.